At this very moment, you are hurtling through space at over 2 million kilometers per hour. Not because Earth orbits the Sun, not because the Sun orbits the Milky Way, but because something out there, something we cannot see, is pulling our entire galaxy toward it. Every star you've ever seen in the night sky, every planet, every moon, the Milky Way itself, containing 400 billion stars, all of it is falling, relentlessly, inevitably, toward a point in space hidden behind the densest region of our own galaxy. We call it the Great Attractor. And after 4 decades of investigation, we still don't fully understand what it is. In 1986, astronomers made a discovery that challenged everything we thought we knew about cosmic motion. They found that our galaxy, along with thousands of others, was being drawn towards something massive, something equivalent to tens of thousands of Milky Ways concentrated in a single region of space, something invisible. What could possibly exert such gravitational influence? Why can't we see it? And what happens when we finally reach it? Today, we journey through the evidence that has puzzled astronomers for decades. We will peer behind the veil of our own galaxy, map structures so vast they defy human comprehension, and confront a truth that reshapes our understanding of cosmic destiny. Prepare yourselves. We begin. Our story begins with a question that seemed simple enough. How fast is our galaxy moving through space, and in what direction? In the early 1970s, astronomers had just discovered the cosmic microwave background radiation, the faint afterglow of the Big Bang that permeates all of space. This ancient light, released when the universe was only 380,000 years old, provided something remarkable: a universal frame of reference. By measuring tiny variations in this background radiation, scientists could determine our absolute motion through space. The technique worked beautifully. When you move toward a source of light, it appears slightly bluer. When you move away, it appears redder. The cosmic microwave background would show this effect if Earth were moving through the universe. And it did. In 1977, researchers confirmed that our solar system was moving at approximately 370 kilometers per second, relative to the cosmic background. That motion made sense. It reflected our orbit around the center of the Milky Way. But then scientists asked a more ambitious question. What about the Milky Way itself? Where is our entire galaxy going? The answer would change everything. In 1986, a group of 7 astronomers, later nicknamed the Seven Samurai, published findings that sent shockwaves through the astronomical community. The team, led by Alan Dressler, Sandra Faber, and Donald Lynden Bell, had spent years measuring the velocities of hundreds of galaxies within 300 million light-years of Earth. Their method was elegant. By studying how fast galaxies were rotating and comparing this to their brightness, they could determine not just how far away each galaxy was, but also how fast it was moving independent of the universe's expansion. What they found was disturbing. The Milky Way wasn't just drifting randomly through space, it was being pulled, along with the entire local group of galaxies, toward a specific point in the sky. And the speed was staggering, approximately 600 kilometers per second. To put this in perspective, at this velocity, you could travel from Earth to the Moon in just 10 minutes. From Earth to Mars in less than a day. We are racing towards something at over 2.1 million kilometers per hour. But here's where it gets strange. The direction of this motion pointed toward a region in the constellation Centaurus, and that region lay directly behind the thickest part of our own galaxy, the zone of avoidance, where dust and stars block our view of whatever lies beyond. Whatever was pulling us was hidden. The seven samurai calculated that to produce such motion, the source must contain mass equivalent to tens of thousands of galaxies concentrated in a volume only 300 million light-years across. They named this unseen mass concentration the Great Attractor.